In this session, we will discuss about modeling of union types using categories. Now, all of the superclass-subclass relationships that we have seen in the previous session, they have a single superclass. A shared subclass such as an engineering manager in the lattice in this figure is the subclass of three distinct superclass-subclass relationship, where each of these three relationships has a single superclass. Now, it is sometimes necessary to represent a single superclass-subclass relationship with more than one superclass, where the superclass represents different entity types. So in this case, the subclass will represent a collection of objects, that is a subset of the union of distinct entity types. And we call such a subclass as a union type or a category. Suppose that we have three entity types: person, bank, and company. In a database for motor vehicle registration, an owner of a vehicle can be a person, can be a bank, or can be a company. So we need to create a class or a collection of entities that will include entities of all these three types to play the role of a vehicle owner. So category owner, that is a subclass of the union of these three entity sets of company, bank, and person, can be created for this purpose. We display categories in EER diagram as shown in this figure. The superclass, that is company, bank, and person, are connected to a circle with the U symbol, which stands for the set union operation. An arc with the subset symbol connects the circle to the subclass, that is the owner category. If a defining predicate is needed, it is displayed next to the line from the superclass to which the predicate applies. So in this figure, we have a category, that is owner category, which is a subclass of the union of person, bank, and company. So a category has two or more subclasses that may represent distinct entity types, whereas other superclass-subclass relationships always have only one superclass. To better understand the difference, we can compare a category such as owner with the engineering manager shared subclass. The latter is a subclass of each of these three superclasses, that is engineer, manager, and salaried employee. So an entity that is a member of engineering manager must exist in all three. This represents the constraint that an engineering manager must be an engineer, a manager, and a salaried employee. That is, an engineering manager is a subset of the intersection of these three classes. Whereas on the other hand, when we talk about category, a category is a subset of the union of its superclasses. Hence, an entity that is a member of owner must exist in only one of the superclass. This represents the constraint that an owner may be a company or a bank or a person. Coming to inheritance, attribute inheritance works more selectively in the case of categories. For example, each owner entity inherits the attribute of a company, a person, and a bank or a bank, depending on the superclass to which the entity belongs. A category can be total or partial. A total category holds the union of all entities in its superclass, whereas a partial category can hold a subset of the union. A total category is represented diagrammatically by a double line connecting the category and the circle, whereas a partial category is indicated using a single line.